Now, corresponding to question, a motor car is going due north at a speed 50 km per hour. It makes a 90-degree left turn without changing the speed. First of all, I know that here north and here south, here east and here west. Okay. Corresponding to question, a car is going on due north at a speed 50 km per hour. 50 km per hour. Okay. So what about initial velocity? Vi is written as 50 km per hour. In which direction? This one is I cap. This one is minus I cap. That one is j cap. And that one is minus j cap. Clear or not? In which direction? That is j. Or you can say 50j. Clear or not? After that, it makes a 90-degree left turn. Left turn means 90-degree left turn means like that one. Okay? Without changing the speed means what about the speed? 50 km per hour. So what about final velocity? Final velocity is written as 50 km per hour. In which direction? 90-degree left. Okay? It make 90-degree left means in which direction? That is minus I cap. So it is written as minus I cap. Clear or not? Now, our motor, the change in the velocity of the car is about change in velocity delta V. It is written as final velocity minus initial velocity. Okay. So final velocity is minus 50 I cap and initial velocity is minus 50 j cap. Okay. If you make this one 50 I cap minus 50 I cap, it is minus 50 I cap and minus 50 j cap. Minus 50 j cap means that is downward. Clear? Minus 50 j cap. That one is resultant delta V. That is delta V. Clear or not? Clear or not? So what about mod V? It is written as under root of minus 50 to the whole square plus minus 50 to the whole square. That is 50 root 2. Okay, it is closer to 70 km per hour. Okay, what about theta? Tan theta is written as 50 divided by 50. That is 1. So theta is 45 degree. Theta is 45 degree. So what about final answer? You can say that 70 km per hour change in speed 70 km per hour and that one is 45 degree. Okay, and this is also 45 degree. So it is just south to west, 70 km per hour south to west. Okay, change in speed, that is delta V, like that one. Okay, so which one is correct? B is the correct option. Make it. Now, a projectile motion velocity is always perpendicular to acceleration. First of all, redraw. Projectile motion direction, like that one. Okay. What about angle? If that is theta, and that is, this one is u, so that is u cos theta, and here u sin theta. Okay. If air resistance is 0, means Ax this is equal to, in Ax direction acceleration is 0. If air resistance is 0, Ax is 0. And what about Ay? That is minus G. Gravity G direction downward always. So this one is opposite to this one. Okay, G is opposite to the initial velocity. It is always downward in all point. Okay. According to question A, projectile motion, the velocity, first option is always perpendicular to the acceleration? No. Initial velocity, that is 90 plus theta. How much angle between these two? That is 90 plus theta. It is perpendicular always? No. Okay. So A is correct, not correct answer. Second one, B, is never perpendicular to the acceleration. It is never. Here no perpendicular, but if going on that point, highest distance, highest h max, velocity direction, that one, and acceleration here. So angle between these two, that is 90. Only possibility, highest point, and here velocity u, like that one. Okay, clear or not? That is u cos theta, that is Vx. Vx is u cos theta, clear or not? And what about Vy? Vy is 0 at highest point. That point, angle between velocity and acceleration, that is 90 degree. So B is incorrect. According to B option, is never perpendicular to the acceleration. Is never perpendicular? No. It is perpendicular at highest point. So B is correct. Incorrect. A and B is incorrect. Now C is perpendicular to acceleration for one instant only. Instant only. So C is correct option. And D is perpendicular acceleration for 2 instant. No, only one instant. Only one instant at highest point. Okay, at highest h max, at highest point, or you can say that at maximum height, acceleration is perpendicular to the projectile motion of the velocity. Okay, so you can say that only one time. Clear? So C is the correct and D is also incorrect also. Okay, make it. Projectile fired at angle 15 degree is 50 meter. I know that if this is R1 range, what about velocity? Suppose that is u, and that angle is theta 1. Clear? So what about R1? R1 is written as, that is u square sine 2 theta divided by 2 theta 1 divided by g. That is the formula of range. I have already discussed. Clear? That is u square sine 2 theta divided by g. Okay. According to question, the range of the projectile fire at angle 15 degree, theta is 15 degree. And what about range? That is 50 meter. 50 meter. Okay. If it is fired with same speed at angle of 50 degree, 45 degree, it means if this one is 15 degree, now second, with same velocity, what about range? That one is 50 meter. Our motor determined R2, and with same velocity means u, and theta 2 is equal to how much? 45 degree. Theta 2 is 45 degree. So R2 is written as u square sine 2 theta 2 divided by g. Okay. Now R1 by R2, first of all put this value. Theta 1 is 15 degree, so u square into sine 15 to 2, that is 30 degree divided by g, and this one is written as u square upon 2g, and this one is written as u square sine 90 degree because of 2 into 45, that is 90 divided by g, so u square upon g. Clear or not? R1 by R2, or you can say that R2 by R1, it is written as U square upon G divided by U square upon 2G. Clear? So that is 2 times this is equal to 2. So R2 is written as 2 times of R1. So 2 into 50, we got 100 meter. So range is increased how much? 100 meter. So D is the correct option. Make it. Clear or not? Very simple. Now corresponding question. 2 bullets are fired simultaneously horizontally and different speed from the same places. Which bullet will hit the ground first? First of all, we have taken 2 bullets, okay, with different velocity. Okay, 2 bullets are fired simultaneously horizontally and with different speed and from the same space, same place. Same place means, suppose that this is height h, so both this one is also h. Okay, here u1 velocity, here u2 velocity horizontally. Clear or not? This one and this one. Clear? This one u1 and this is u2. What about angle between these two? 90 degree. What about G? Downward. Here G downward. What about vertical velocity of u1? That is u1 cos 90. Here u2 cos 90. Okay. V, that is 0, cos 90 is 0. So Vy 0 in both cases, in that one and that is also. Why? Vertical component 0, vertical component of the velocity is 0. So initial velocity of that one 0 and initial velocity of that one is 0 in y direction. So Vy is 0 in both cases. I know that h is written as uy into t plus half g into t square. Both height are same, capital H, capital H. Vy is 0. So we got 2g into t square. So what about t? T is written as under root 2h by g. Clear or not? Under 2h by g. Means both are taken same time. Okay, both are taken same time. Clear or not? Both are taken same time. Hit the ground. So faster one, no. Slower one, no. Both are reach simultaneously. So C is the correct option. Make it. Why? Because both are not depend upon. Both are depend upon initial velocity. Initial in y direction in both velocity are 0. So both are hit simultaneously. Okay, it means you can say that you have taken same time. Take same time. If this one hit in 5 seconds and that is also hit after 5 seconds. Clear or not? Make it. Now corresponding question. The velocity of a particle is 0 at t is equal to 0. Mean initial velocity is 0. U is 0. What about acceleration? That is v minus u divided by t. The acceleration, first of all, according to question, the acceleration at t is equal to 0 must be 0. Must be 0. It is possible or not? Take example. Suppose that this is ground from h height. A particle or a ball Okay, what about initial velocity at t this equal to 0? That is 0. That is 0 or not? Initial velocity of this pen is 0 or not? But what about oscillation at that time? That is G, ground. That is A. So A is 0 or not? No, A is not 0. But U is 0 at t this equal to 0. So A is incorrect option. Clear or not? Why A is incorrect at t this equal to 0? If free falling, suppose that this one is a pen is at h height. Okay, U is equal to 0 at t this equal to 0. But what about acceleration due to gravity? So A is not 0. A this equal to 0. So you can say that U is at t this equal to, if U is 0 but A is not 0, A is equal to G. So according to question, acceleration must be 0. No, it is not must be 0. So A is not correct. Now second one, acceleration at t this equal to 0 may be 0. May be 0? Yes, why not? I know that V is written as U plus A into T. If this velocity is 0 and U is also already given 0, so what about A? A is also 0. You can say that V minus U divided by T. If this one is 0, this one is already given. If this one is 0, then what about A? Is also 0. So maybe, according to question, maybe, yes. Now next one, if the acceleration is 0, if the acceleration is 0 from t this equal to 0 to t this equal to 10 seconds, t this equal to 0 to t this equal to 10. From 0 to 10 means t this equal to 1, t this equal to 2, t this equal to 3 and t this 4, 4, 5, 6, 7, 8, 9, 10. The speed is also 0. The speed is also 0. Speed is also 0 means second part, sorry, third, C. If A is 0 at here, in all point, or you can say the A to 10 second, in between 0 to 10 second, acceleration is 0. Then what about velocity at t this equal to 1 second? V this equal to U plus A into T. This one is also 0 and that is 0 into T. T is equal to, if T put 1, 2, 3, whatever value you put here, then V is also 0. Clear or not? So according to question, the speed is also 0 in this interval. Clear? 0 to 10 second. What about velocity? 0. So you can say that C is correct option. Now last one. If the speed is 0 from t this equal to 0 to 10 second, the acceleration is also 0. Final speed. Now, if final speed means at t this equal to 1, t this equal to 2, t this equal to 3, at t this equal to 10 is 0. Okay, in all. Okay, this one 0. So what about A? A is V minus U divided by T. Okay, put here, if this one is 0 and this is also 0, initial velocity already given 0, so acceleration is always 0. So D is also correct. Only A option is incorrect, B, C, D, these three option is correct. Okay, make it. Now corresponding question, three forces F1, F2 are represented as on figure, each of them of equal magnitude. Means F1 this is equal to F2, this is equal to F3, that is F. Clear or not? These three are equal magnitude, that's why. And here F1, here F2, here F3. How much direction? 45 degree. Given. Our target, we are focused on F1 plus F2 plus F3. I know that We have focus on what about basically we have focus on resultant direction. We have focus on what about resultant of the direction. Okay. So how can I know that this value of magnitude wise f and this is also f. What about resultant of these two? If you redraw, that is f, here f and here also f. Resultant of these two, like that one, because of f square plus f square, under root of f square plus f square, that's root 2f. Root 2f at 45 degree, and that is f. So resultant of these two, so resultant, if this is f and that is root 2f, so net direction here root 2 minus f, we got that is positive. It means resultant of these three because of going on here. So which one is correct? A to Q. So you can say that A to Q. A belongs to Q. Clear or not? Now next one. Clear or not? Resultant of these two, because of all forces magnitude are same, so you can say that resultant of these two, that is root 2f, because of f square plus this one is f I cap, here minus f j cap. So resultant of these two, we got root 2f. Okay, so direction of that one root 2f and here f. So net direction here root 2 minus f, that is positive whatever be the value, but we have focus on magnitude only direction. So A to Q. Clear? Now next one, f1 minus f2, second option B. We have focus on B part. f1 minus f2 plus f3. So first of all redraw. Redraw that one. Okay. Now f1 minus f2 plus f3. f1 minus f2. f1 direction like that one. f2 direction like that one. Minus f2 direction like that one. And f3 direction like that one. Resultant of these two, that is root 2f. Clear or not? Resultant of these two, that is root 2f. How much angle? 45 degree. And this one is also already given 45. And this is f, magnitude wise f, and that is root 2f. So resultant of these f square plus 2f means you got root 3f. Okay. So resultant of these two, we got here. In this direction. Okay, clear or not? Clear or not? So which one is correct? B to R. B to R. So you can say that B to R. Clear? Clear or not? Not 45 degree. Okay. Now next, f1 minus f2 minus f3. Next target is we have focus on f1 minus f2 minus f3. We have focus on next one, f1 minus f2 minus f3. So how can do it? Now third one, f1 minus f2 minus f3, that is minus f3. So first of all redraw f1 like that one, minus f2 means like that one, and minus f3 is going on here. Okay, what this is f and that is also f and that is also f. So resultant of these two going on here, f plus root 2f. So you can say root 2f plus f. That is the resultant of these two. Okay. So what about, basically we have focused on direction. So direction is, you can say C to P. Okay. Resultant is that one. That's why. So you can say that C to P. Now last one, F2. F2 minus F1 minus F3. F2. F2 direction, that one, minus F1, like that one, here F, and minus F3, that one. Okay. Resultant of these two, like that one, and resultant of these two, that is root 2f. So resultant of these two we got here. Okay. So which one is correct? D2S. So D2S is the final answer. Make it.